Thank you for joining Spinnaker.Live today. We hope you enjoyed the main stage presentations, and this is a great virtual event to keep the global community connected. Some housekeeping notes to remember during our presentation. Type in questions to the chat function and we'll answer throughout the presentation, and engage with other attendees through the portal. After the breakout concludes, head over to the main channel for games and prizes during breaks. And Praneet and I are here to talk about some interesting new developments integrating Pulumi with the Spinnaker ecosystem. My name is Dan Hernandez. I'm a customer engineer with Pulumi. I've spent most of my career working with organizations on their infrastructure as code and cloud modernization projects. With that experience, I've seen a lot of common patterns and pain points, and that's what really brought me to Pulumi. And it also happens that many of our users are really curious about what the story has been between Pulumi and Spinnaker. And that's why I'm excited to show what we're showing today. Praneet.
And I'm Praneet Loke. I'm a software engineer at Pulumi, and I work on our service and CLI tools. I am absolutely excited to be showing off our Pulumi plugin for Spinnaker today, so I can't really wait for us to get to the demo slide.
And today we're going to talk about Pulumi for a couple of minutes for those of you who are unfamiliar. And we'll talk about how we got where we are today and why. And we'll spend most of the time walking through a demo. So a little about Pulumi. Pulumi is really the next evolution of infrastructure as code. And I like to say that it puts the code back in infrastructure as code, meaning you can define your infrastructure declaratively using real programming languages. So no YAML, JSON, or proprietary DSL that you need to learn or stub your toe on. You can use any language that you prefer, as long as it's JavaScript, TypeScript, Python, .NET, or Go. And Pulumi is a full engine. It's a CLI tool. It's a SaaS product, and it really makes it easy for organizations to adopt modern cloud technology and infrastructure as code best practices. And I won't dive into each one of these. And that said, I really want to get into what we're here to talk about today. And, we've seen a lot of interest in the story between Pulumi and Spinnaker from our users and from our customers. And so we joined the Spinnaker Gardening Days back in April as a way to kick off our involvement in the Spinnaker ecosystem. So the Spinnaker Hackathon was a really great event and experience. Just one colleague and I joined thinking we would be working alone, but we actually ended up recruiting 16 different community members into the channel. And throughout the hackathon, there were anywhere between 5 to 10 people active on a long-running Zoom. And we won the hackathon. So, shout out to the community and those that participated. Again, it was a great experience. Definitely keep an eye out for the next one. I promise it'll be a really cool experience. The team over there, AKA Rosalind from Armory, just did a really superb job, and it was one of the best run events I've personally participated in. And to talk more in depth about how we see Pulumi and Spinnaker working in concert, there are multiple ways that can kind of piggyback or turtle on one another. First, you can bring up a Spinnaker cluster using Pulumi. That is a Kubernetes cluster and the right set of containers, and all defined and deployed using Pulumi. We haven't done this yet, but we've been playing around with it, and it would be really awesome to see some open source examples around this from the community. You can also actually manage the resources inside of the Spinnaker cluster like a pipeline using Pulumi. Pulumi has a concept of providers that just require an API. A while back, we took a stab at this for an internal hackathon. So it's not officially supported, but completely possible, and another great open source project opportunity to consider. And finally, and more specifically, where we started in the hackathon is deploying cloud resources in Spinnaker pipeline using Pulumi. So think base infrastructure like Kubernetes clusters to Kubernetes apps to S3 buckets, and really any other cloud resources that are needed to build a modern cloud application. In the hackathon, we made some really good progress, but it was certainly a hackathon, and the result wasn't quite ready to be consumed more broadly. So since then, we've put in some additional work to really bring that solution into preview, absolutely ready to use, open sourced, and we're really excited about getting folks using it, giving us feedback, and collaborating on improvements. And with that said, I'll hand it over to Praneet to show us what he's been working on.
All right, thanks, Dan. So as I mentioned before, I've been working on the plugin with Dan and the folks at Armory, and it's been really amazing to basically understand the whole concept of the Spinnaker ecosystem and the Spinnaker service itself. And so I wanted to first start with an overview of the plugin that we've built, as well as show the Pulumi app that we will deploy using an example pipeline in Spinnaker. And we'll also look at making changes to the Pulumi app and deploying that using the same pipeline. So throughout this, basically, I will be shifting between my VS Code and my local Spinnaker instance, which has been enabled by Armory's Spinnaker. So without further ado, let's go look at our pipeline. So when we worked on the plugin, we wanted to keep in mind that users should be able to work with any VCS where their source code is located. And this could be a public or a private repository. And given that Pulumi allows you to write Pulumi apps or author your infrastructure in any of the supported programming languages, you also need a way to restore any dependencies that your Pulumi app could be depending on. And also, because we roll out CLI releases, you should also be able to pick a specific version of Pulumi that you would like to run run the Pulumi CLI against. And also, because the CLI supports a lot of commands, we also wanted to allow you to specify the command that you would like to run and pass the arguments that you want for the command. And Pulumi also has this concept called a backend, which is basically like Pulumi, whenever you run Pulumi preview or Pulumi up, Pulumi tracks the infrastructure state with a specific service backend. And so this backend out of the box is the managed service backend identified by api.pulumi.com. And of course, you can change this to be a self-hosted backend, or it could be even AWS S3 or GCS or any of the supported backends. And you can look at the documentation for using a backend on pulumi.com/docs. And lastly, we also wanted to give a way to specify secrets that you would run with the Pulumi app. So for example, if you're running a Pulumi app that deploys resources to AWS or GCP or any of the other supported providers, you need to be able to pass those secrets to the execution environment in which the Pulumi CLI is running. So for this, basically you will define a Kubernetes secret resource, and then the secret resource will can contain any of those environment variables that Pulumi expects for each of those providers. So So basically, those are all of the inputs that the plugin itself provides. And for the example pipeline, I thought it would be really good to demonstrate deploying a Kubernetes resource into the same cluster that the Spinnaker instance itself is running, as well as trying to deploy some AWS S3 resources. And so our sample app for S3 will basically deploy a static website, which involves creating an S3 bucket and then configuring bucket policies on that, and then also uploading some bucket objects, which will then be marked with that bucket policy. And for the Nginx resource, which is going to be a Kubernetes deployment resource, the Nginx container will be deployed with default configuration. And so we're not going to be exposing the container outside of the Spinnaker cluster itself. But because we're deploying it within the cluster and this is a local installation, we can ping that default installation and see the response from Nginx itself. So let's look at the Pulumi app itself. As you can see, we're making use of the Kubernetes package to define the various resources. I have a config map with some key value pairs that my deployment cares about, and you can see it's pretty easy and idiomatic to TypeScript in this case. How you would create new resources and basically reference those resources as simple as just local variables throughout your infrastructure resource. And so my config map resource is used by my deployment resource, which tells Pulumi that the deployment resource cannot be created until the config map resource itself is created and ready to be used. And of course, we map the name of the config map resource as the ref for pulling all of the key value pairs out of config map and mapping them as environment variables for our Nginx container. And so when we run this pipeline, we can see that Pulumi basically creates the config map and then starts to create the Nginx deployment resource. And you can see that Pulumi orchestrates the creation of this Nginx or this deployment resource and then waits for the pod to be ready before it marks the deployment as complete. And so once the pod is ready and initialized, Pulumi basically ends the deployment execution and then gives you the results, which you can then view on the Pulumi console using this permalink for this update. And if we look at the S3 update itself, pretty simple. We create the bucket policy, the bucket, upload a couple bucket objects with the same bucket policy that we defined, which if we look at that, it's basically a regular bucket policy that allows public access on any objects uploaded to that specific bucket. And we want to do this because this is specifically for a static website, which it's okay to have anonymous access and specifically public access, because normally you don't want to have private access or public access on sensitive buckets. So let's take a look at creating or making an update to this. Now creating these resources is great, and creating this in my Spinnaker instance or Spinnaker cluster is great. But the thing about these two resources is I've not specified the namespace here, which means these two resources are created in the default namespace. And that's not really great because typically teams want to have their resources namespaced accordingly. And so in this case, I want to have these two resources in an app namespace, because this is something that all of my app resources, I want to put all of them into a specific namespace. And And so I've already saved the code for doing this, but let's take a really quick walk through this. So the changes that you'll notice is that there's a new resource now, which is basically create a new namespace and then using that namespace throughout the rest of the app itself. So basically that's our config map and our deployment resource. We're going to use the namespace itself, which involves specifying the namespace property inside the metadata for the config map and deployment resources. So, so this is really great. Let's go ahead and commit this and push this up. Normally, you would go through the GitOps workflow and make sure that your code changes are reviewed, and you have a PR workflow, which you can even use Spinnaker to get a webhook trigger for your pull request, such that you can run a pipeline that runs a preview for the changes that you're proposing. But because we're doing a demo here, I'm going to skip past some of those things, and I'll show you the pipeline view of what happens when we apply these changes, as well as also look at the preview itself to see what that looks like. So whoops, let's go ahead and save that resource. And push it up to master. Great. I've already gone ahead and made run an execution of that pipeline, which has those changes with the namespace addition. So let's take a quick look at the preview itself. So as you can see, the preview basically says that there is now a difference in the metadata from what was previously deployed. And so Pulumi detects that it needs to replace the config map and the deployment resources. And before that, it needs to first create the namespace resource. And so Pulumi automatically orchestrates the creation and replacement of these resources. And so first proposes creating the namespace resource, and then followed by creating the new config map resource, and then finally removing the old config map resource. And then the same thing happens with a deployment resource for the Nginx container, which gets created in the new app namespace, and then the old Nginx container, which was running in the default namespace, then gets removed or deleted. And so once that's done, then Pulumi basically says the deployment is over. Sounds pretty simple. And if we look at the S3 changes, we actually did not change anything, which means the 5 unchanged output is totally valid because we did not touch a thing, which means nothing should be updated. This is exactly what I would expect. And as you can imagine, if you're doing a pull request, this is exactly what you would be looking for when you have a triggered build for pull requests, basically evaluating if your infrastructure is being changed unnecessarily or accidentally because you changed something else. Finally, if we look at the actual update stage itself for our changes where we added the namespace, we can see that the namespace gets created, and then the new config map gets created in the new namespace, and then the old one gets removed. And then the same thing happens for our Nginx container itself, creation followed by a replacement, and then eventually also waiting for the container to fully initialize, and then Pulumi basically completes the deployment. And once again, we get a permalink for this update to see what were the resources that were changed and what was the detailed diff between the previous state and the current state. So that's great. So because the deployment is complete, we can go ahead and query our app's namespace in our Kubernetes cluster and see that we do have an Nginx pod here with an internal IP address of 10.42.0.240. So let's go ahead and query that. And you can see that I get a default Nginx response, which is totally valid because I've not done anything other than just deploy the default Nginx image as a container in my existing cluster. And it's accessible within the cluster, and I get the valid response. So looking great. So when I'm all done, I can go ahead and run a destroy job, which a destroy job uses our plugin again, but instead of running the preview or the up command like I showed before, it runs the destroy command, which goes ahead and tears down the infrastructure. So you can imagine how putting these two commands together, you could quickly come up with a pipeline that simulates sort of an ephemeral testing environment. So you could think of scenarios where you have an application that you want to test in the real world scenario. So you want to set up some infrastructure, run some smoke tests against it, and then quickly tear down the infrastructure. This is really possible with Pulumi because it doesn't take a whole lot to actually achieve that scenario. So I'll go ahead and kick that and let the destroy run and delete my resources for me. But that's pretty much all that I had to demonstrate for you all today. But I hope that you will check out the Pulumi plugin for Spinnaker. It is open source. We hope to get some feedback from the community, and hopefully we can work with you to add more features to it. So with that, I will give it to Dan.
Thanks, Praneet. That was an awesome demo. Yeah, I'm also really excited about bringing this to the community, and I want to give a special thanks to Armory. I think they've spent a lot of time with us on building the plugin and showing us how to work with various nuances of Spinnaker. They've been working a lot on the open source aspects of the plugin framework. So, very thankful for that work and look forward to continuing to work with them and seeing the work that they're doing. And next steps for the viewers. So get started with Pulumi. It's really easy. It takes about 15 minutes through our Getting Started guide. Join our community Slack. That's a great place to ask questions and understand everything that's going on surrounding Pulumi and being able to interact with other folks in the community. And definitely try the plugin out for yourself. We'll share some details about how you can get access to this. And it would be great if you in the community would create and can contribute open source projects. Pulumi is an open source tool, and we're really excited about the opportunities to expand the ecosystem and work with a lot of different organizations and teams and people on various different projects. But for this specifically Spinnaker, there's a lot of different opportunities here. So last thing here, we have a trivia question for our final slide. Please put your answer in the chat function and we'll select a winner at random that answers correctly. And connect with us via Slack or Twitter. And enjoy the rest of Spinnaker Live. Thank you.